Okay. Um,
All right.
I
Just see if audio is working.
Yep, I think it should be.
It is. Cool.
Okay. Nice. Well, hello everyone, and welcome to this OTTO Development stream. We have a little bit of a plan of what we're gonna do, but I think the first thing we're gonna do is look over the plan and figure out if it's a good plan. I'm
Yeah.
just gonna.
Should we go over some context first? Just a little bit.
Yeah, sure.
The big picture stuff. What we're gonna do tonight. So basically, the construction of the auto has been, well, relatively simple. It's all been on, everything has been on one huge PCB where everything has been gathered. Then there's been some smaller boards, like the screen has been on a small PCB on standoffs from the main PCB and that sort of thing. But there was some problems with that, which is one thing of just space. It's a lot of stuff to fit on one PCB, and another one is there's a bunch of small things, which is like the LEDs. They are sitting on the main PCB, but then there's quite a big gap up to the front plate, which causes light bleed from one LED to the next. So what we're gonna do is we're gonna move a bunch of stuff from the main PCB up to an auxiliary PCB, which is about the same size as the main PCB. So that lets us put LEDs and put the screen and a bunch of other stuff on that PCB.
Yeah. I think I'm not actually sure what the best way to show it is. I don't currently have the old project open. But if I just maybe if I open a render of this board, I think that should work. But yeah, the biggest part was that the LEDs we used on the previous version had to be hand soldered, and that took like 2 hours and was a major pain in the ass.
Yeah, so putting them on a separate PCB allows us to get it assembled by a machine, which of course, as soon as you have something repetitive, then you figure out a way to make a machine do it.
Yeah, so on the old board we also had smaller buttons on the last version, but yeah, all the LEDs were right next to all the buttons. And now we're gonna have another board sitting above this one, which will have the screen and the LEDs, and that's probably it.
Yeah. Another reason is the screen, because we used to use these kind of breakout boards for screens. So we would buy the screen already on a breakout board. So if you see these LCD screens that you buy from China, they have these 50-pin FPC connectors. They're a pain to solder. So it's very nice to buy these screens already on a breakout board, but it's quite inconvenient because maybe the exact screen you want is only available for half a year, and then they run out of stock. So if you want something to be if you want to be sure that you can keep doing it, if you can keep getting the screen you want, then you need to do it yourself. So we
Yeah.
would have to make the breakout boards ourselves anyway. So at this
Yeah.
point, why not just make one big PCB, put all of it on that?
Yeah, and we actually did make those. We did make those breakout boards for the first beta iteration, uh, just to test the new screens mainly. Someone is asking about the programs we're using. This is just KiCad. We use KiCad because it's free and open source, which just makes it easier for everyone to contribute and to look at the files and all of that, including ourselves. So, and also it's I mean, I haven't used anything else, but we've had no issues with it.
No, I hear it's come a long way in the last couple of years.
I think I tried it a few years ago, and I think the main issue was that the user or the symbol and footprint libraries were very small, I think, which makes it very hard to start out. But now mostly everything's in there. We had to design a new power circuit a few days ago, and I went in and did the symbol for the power chip and forgot to check in the standard library, and of course it was there. So that was a waste of 15 minutes. Okay, I guess. Yeah, so the state of this currently is the main board is, I think, close to completion. We still have some issues to resolve around this, mainly how we're gonna do. We have these headers for a possible expansion board for battery management in the future. We'd like to at least keep that option open. So we just gotta be sure, which points you need to be able to hook in, and how we're gonna do the defaulted jumpers and all of that. But other than that, I think the main board is mostly done, except. So let me just. This is the aux board. We have an issue with the size of the holes for the main keys, because these holes are made to fit. Let me maybe just try to get a picture of. Get a picture of the keycaps. It's kind of visible here.
Someone is asking about power supply, USB, and yeah, the power supply is still a little bit of an open question. For this version, we're going to scale the ambition back a little bit, so to speak. But we're gonna go for just a normal barrel jack power supply for this version. But we do want to make other kinds of power supplies available. It's just for development, it's easier to just have a single way of doing it.
Yeah. Also, power. I don't know a lot about it, but supplying power over USB is a bit hard, because if you're USB compliant, you can only pull like 500 milliamps, which I think most people don't do. So the right way to do it is to use USB-C and negotiate power and all that. And it's something that would make sense when we get an expansion board for battery management, but we have done it now, so that expansion board could hook into the USB power and use that for charging. Because USB power is mostly useful when you're bringing it somewhere and don't want to bring an extra charger. Someone's asking about who is who. You can see, hi, I'm Tobias, but you can see down in the bottom right corner who's talking.
Yeah, and I'm Jonathan. We should mention that Tobias is the one controlling the computer right now.
Oh,
so you're
yeah,
the one moving stuff
too.
around.
Yeah. Right. Okay. So the render that I have here is of the old prototype, which colloquially is called the Proto, and yeah, it's the same keys as we're going to use now, and you can see these keycaps kind of have a lip at the bottom, I think, to prevent them from falling out if they're mounted. If they're mounted so they're not stuck to the keys. But we were hoping that the top board would be above that lip, which I don't think it will be, which makes the construction kind of hard, since we're probably going to need quite a bit of space around the bottom of those keycaps, meaning, as you can see here, the LEDs are going to be too close to the holes. So yeah, I think the outer orange ring here is the outer ring on the keycaps. So we're going to have to move these the bottom white keys here down by a few millimeters to give us enough space for the LEDs, which isn't really a big issue, but that means that we're gonna have to do some amount of rerouting on the main board as well.
But now there's a lot more space, so
yeah, so
should be possible.
Yeah.
So yeah. You can also compare it to the picture you were just showing. We moved the LEDs on top of on the top side of the buttons. We didn't think of the fact that, of course, you're gonna cover the LED with your fingers when you're pressing them down. We didn't catch that until we actually had a finished prototype in our hands, and the LEDs were lighting up. So yeah, I don't know if there's any lesson to be learned there. I don't know.
I think it's just that's why we make prototypes.
Yeah.
And it's also important to get far enough with the prototypes that you're actually able to evaluate them to some extent.
Yeah. So this is the auxiliary board that you're showing now. So you can see the big yellow, there's a bunch of holes, the yellow circles for the big keyboard buttons and for the function buttons up in the upper right corner. Then all the red pads are for the LEDs that are going to be mounted. The screen is in the middle, which we're going to route. And then to the right, to the left, upper left corner are the holes for the encoders. That's basically all there is.
Yeah, and then there's also there's some questions about physical constructions, physical construction with the case. We're gonna get a sheet metal, a folded sheet metal powder coated case. So we'd like to be able to access all development headers. We have some UART ports and a JTAG connector for the MCU. We'd like to be able to access all of those from the top. So they got to be placed on the mainboard somewhere, probably in this region, which is gonna be and then we gotta make holes for them here. So yeah, I think this area will probably be maybe even just like one big hole or something.
Yeah, probably. Should we get started routing some stuff? Or
yeah,
is moving the buttons might be the first one?
I think
or you know what, let's start routing the screen. That's maybe more that's more
I think we should try to position everything first, even though that part of the board probably shouldn't be changing. I'm also just looking at some questions. What possible expansion I/O headers on this board? Yeah, so we have for the power supply board over here, there's just a few also general purpose I/O pins from the MCU exposed here. Then we're actually not quite sure, I think, what we're gonna keep and what we're gonna add and stuff like that. There's also some things with on the on
the audio.
Yeah, on the audio side. So possibly we could make a speaker expansion board for it. Yeah, I don't think we're gonna put a lot of effort into trying to plan what we could do with these things. We're just gonna try to route the unused connections that are easily routable to some headers, and then we can solve that issue in the future.
For now, the goal is to get to some sort of minimum viable product.
Yeah. Also, someone's asking about firmware updates. So we're probably not going to be able to do the updates over USB, because the USB communicates with the MCU, and then we'd have to probably send it over MIDI SysX or something through the MCU and then to Raspberry Pi and stuff like that. But I think we're probably gonna do like either you can open it up and pull out the SD card if it's if in the worst case. You can always do that if for some reason the normal updating system doesn't work. And I think the normal updating system is going to be something like you put a file on a USB on a pen drive that's formatted the right way and plug that into the Raspberry Pi port.
Basically like the RetroPie, like transferring ROMs.
Yeah.
If anyone has done that.
Yeah. We did actually talk about updating over Wi-Fi. I think we're gonna, for various reasons with power and lots of things, we're probably gonna disable Wi-Fi because there's not really. I mean, there are some possibly interesting use cases for it, but it's. I think it's a fair constraint to just disable it. And also we want to at some point in the future switch to a compute module, Raspberry Pi compute module, because that gives a lot of advantages, but that doesn't have Wi-Fi. So we're probably not gonna design any features that really rely on it. But it has been very useful for development.
Yeah, definitely. It's some people have experienced some problems with the Wi-Fi module on Raspberry Pi. I don't know if it's on the 3A Plus or it was previous versions, but some people have been seeing like latency spikes with the Wi-Fi module turning on and off, which is pretty bad when you have a real-time kernel.
Yeah, in general, I think my approach to most of these things is that when in doubt, just dumb it down, and try to keep it simpler. And that goes for Wi-Fi as well, and for this whole trying to build a stable, real-time capable Linux system. Just removing everything that we're not gonna need, especially because as long as it's just software, we can always add things in an update. Yep, exactly the KISS approach. Okay. So
did you want to start positioning some stuff?
Yeah, I think the best thing to do is to start by figuring out how big these footprints need to be. Because that tells us how much space we need for the LEDs, etc. And this is obviously now a bit awkward to do on stream, because I have to go get my caliper and measure one of these, and we don't have a camera. But
I don't know. Do you have any ideas what I could be talking about in the meantime?
We can just ask people.
Someone is talking about Bluetooth headphones, and I think it's probably true that the latency is not going to be good enough. It's for music, it's pretty strict. You don't want to get too far above 10. Tobias, could you mute your?
I'm gonna do that.
I don't want to get too far over like 15 milliseconds latency for live music. I think so. Someone is talking about LED buttons, which we have thought about, but the kind of LED buttons you can get, I know like Adafruit makes some buttons that they have an RGB LED in there and you can press it, but it's very the feel is not nice, and definitely if you want to use it for a keyboard, then the feel is not good.
I mean, getting just passable buttons is hard enough in itself.
And the buttons we're using now is definitely leave some to be desired still. We that's very high on the wish list for things to do when we have a functioning version. Then we want to look at how can we make the experience better, and better buttons is definitely a part of that.
That's something where there's been some discussion on Discord, I think, lately about custom parts and all of that. And that's definitely something where the main problem is that we need buttons, we need existing keys, and we need existing keycaps, and these are one of the few combinations that live up to all of our requirements. We have upgraded
mechanical switches, as Patrick is saying, actually.
Yeah, the very first, the two first very early prototypes we built are using mechanical switches, but but then there's once again issues with keycaps, because then either we need keycaps with custom icons in them, or we need to somehow have space for the icons next to the keycaps, which would make the whole thing very big. And
I mean, they could be used for the keyboard itself, but sourcing them is also a bit of a hassle.
They're hard to source. They're also physically very, very tall, and then they're just very expensive. And I personally don't think it's quite worth it. At least while we can't do it right.
We might go back to them or something else, but
Um,
yeah.
Yeah, Adafruit has silicone buttons. Yeah, they are also hard to put. I think there's multiple problems with silicone buttons. They also just, I don't think they're actually that nice to use as keys. I don't think these are considerably worse.
The Kyle switches that someone mentions is those were the ones that we used in the early prototypes. Yeah, the low profile mechanical keyboard buttons.
Yeah.
Soft switches, membrane. Then I think those are pretty hard to assemble by hand. I think, or I might be messing up with the butterfly switches.
I think the scissor switches. I think the main issue again is it's hard to get these as non-custom parts. That actually also goes for the silicone ones. We then have to get these square grids and cut them up. Meaning for the black keys we'd need that just be two grouped together, which would make it hard for them to be mounted and all of that. Okay, I have a keycap here and I've measured it, and I think it's kind of hard to tell because I think we're gonna want a good amount of space around it because they move a little bit, and I'm not actually sure. Maybe I should just be actually measuring this properly in the old prototype. But so the auxiliary board is gonna be 2.2 millimeters below the top plate because that's the thickness of the screen. Oh, look at that, I hit 2.2 perfectly here. So right, that's gonna put us there. I think basically when the switches are in the normal open position, the top of the lip of the keycaps is flat, is flush with the top of the aux board.
Right. Have you accounted for the width, the thickness of the aux board?
No, because I'm talking about the top of the aux board.
Okay, sure.
So yeah, I think that means that because travel is basically nothing, I think that means the lip is never gonna get underneath the auxiliary board, which is good because that means it can't get caught on the edge, meaning we can probably make do with very small margins. But the annoying part about testing it with very small margins is if those margins are too small, then we have to make another iteration where we move the keys even further apart. We're probably just going to give it a bit more space and then not worry about making the whole board 3 millimeters larger than it needs to be.
Sounds good.
So I guess we can go with 13.5 millimeters. That's
how much of a margin is that? 0.3?
That's 0.5 millimeters.
0.5,
which is actually I think more than we need.
That's quite a lot.
But also there's also tolerances with how with how precisely we can solder the keys in the exact right position, things like that.
That's
Which
true.
that
Yeah.
shouldn't be an issue actually, because it has guiding pins.
They can always slide a little bit.
Well, not necessarily. It has like two plastic guiding pins.
Oh, those. Okay. Oh, that's nice.
Yeah. So if we just make those holes small enough, they should. Yeah, they should fit perfectly, I think.
Sure. Let's go for it.
Yeah. So that means how much space we're gonna give it? 13 millimeters. 13 point. That doesn't really matter actually, but 13.3. I'm gonna go with 13.3, I think. Okay. That means we need to
edit
wait,
that
what?
footprint.
Yep. Nope. Wrong button.
No.
Edit library footprint. Yeah, exactly. Someone's talking about finding the height of all of these parts and finding the correct position to put the aux board in. And yeah, and that's definitely why it's very nice that we now have 2 iterations of PCB of PCBs to measure on, and we have the KiCad 3D models, which we're gonna have to do a full CAD assembly of these things, because we have 2.2 millimeters above between the aux board and the front plate, meaning we have to make sure that every capacitor and we have a small LED control IC up there, which I'm fairly certain they're not 2.2 millimeters tall, but we gotta be sure.
Yeah.
And that's why this takes a few iterations, and we've mostly been lucky so far, I think. Okay, I think I can just take this hole and 11.7. Let's try. What did I say? 13.3. And then I think 13.3 over here as well. Okay. Yep, that looks right. Okay. And then we can just we should be able to do something like this. And now this is the right button to press, and update footprints with that identifier, and let's go. And yes, nice.
Very
okay
nice.
So now this is where I shouldn't have just praised KiCad a few minutes ago. Okay, I think this should be fine. So point is, I'd like to grab these. I think I got the yeah. Oh, damn it. Okay, let's maybe just start by moving the LEDs down.
Rotating those?
No, I think that only makes it worse, actually. I think I've tried that. But if we do, I'm just gonna do this, and can I unlock all of this?
Don't move the corner holes.
Well, it doesn't really matter. We're gonna have to move it all anyway.
Yeah, I suppose.
Yes, I do want to continue. Okay. Can I not Locking. Unlock. Okay, I can do that. Then why couldn't I? Something like that? Oh, that was because I had some text selected as well. Okay. Oh, that was hi Bastian. That was Bastian talking about the heights of all of the parts.
Yeah.
And yes, those darn encoders, I couldn't agree more. Okay, what exactly we're gonna do here? I think so. Now it's all unlocked, so I should be able to do something like this, maybe. Oh no, I want to start out by moving the LED down to a point where it looks like it has enough space. I think. Can I do something like? I can't. Fuck. I don't understand how to manage something like this in KiCad. When you have like a reasonable way to manage a grid of components. I'm also interested in finding out how big the LEDs actually are. I know it's not really to be trusted, but I think that yeah, the 3D model kind of tells us something. So okay, so this one definitely has enough space above it now.
More than enough, yeah.
Yeah, well,
I mean,
I guess we could move it up a little bit, but it's probably better to be a little bit on the safe side. We could move it up a little. I don't think I should have that open at the same time. So if we do something like this and move it up to about there.
Yeah,
Okay.
I think so.
And then something like so we have the I should be able to get the
Actually,
right,
I think
the Y position.
I think it's going to be nicer actually to get the keys a little bit further apart, because you do end up scrunching your fingers up.
Well, the keys are
Because
gonna get.
Because no, I mean the black keys and the white keys, getting them further apart.
Yeah,
I think it's going to feel more natural. Have a little bit more space.
Yeah, I think so as well. I think it's gonna be good.
Yes, the LEDs are SMD.
Yeah, that's
one of the
big. Yeah, talk.
One of the reasons for doing this is so we can use SMD LEDs and have them assembled from an assembly house.
You know what? I think I'm just gonna. So these are.
So for what Michael? Sorry, I don't want to break your concentration.
Oh yeah, no, it's fine. Just talk.
But yeah, what Michael is asking about, if you get this as an alpha tester, and then there are any further iterations.
I mean, I think it's definitely something we'd, if possible, to some extent, like to do. But we, yeah, I mean, we are trying to somehow be. We have to try to make it an at least partially sustainable business. And yeah, I don't think it's probably not going to make sense to upgrade boards in an existing version. I don't think there's going to be much to save, since we want to do a lot of very big improvements.
Yeah, but I think the idea is that for the software at least, and the alpha version can get you quite far. But I don't think it's going to be possible to just desolder a Pi and then put on a different one.
Yeah, and we're probably also not going to be able to make like expansion boards which fit in the same, or new main boards which fit in the same case or something like that.
But once these get out there, we're not gonna change to a different Pi for a long time.
Yeah, when we're talking about a next version, we're talking about whenever we probably in a few years have the means and also have experimented enough with this to actually be able to design and produce that. Okay, so I'm gonna see if I can do this. I'm just gonna open. Which one was it again? It's the OTTO aux SMD dot PCB, something like that. KiCad PCB, that's the name of it. And then I'm just gonna use some text editing magic to try to. I should probably close this one first. So I'm trying to move all the LEDs that are currently at Y 179.75 to another position that has a lot of decimals. So I guess just close this one first. Okay.
This is the kind of thing that could definitely be solved within KiCad just using the scripting tool, but yeah, sometimes it's nice to show off your editor skills.
All the damn hours I've spent setting up this text editor can't be for nothing. Which, speaking of being for nothing, why is there only one occurrence of that value? Huh?
Well, that's the new value, isn't it?
Nope, it's just me pressing the wrong button.
All right. Sure.
Okay, so all of these are the LEDs. Yes, right. Yeah. Okay, so I can do that and select. I can do that. I can do that 0.75 and select those, and I can do. It's been some time since I've used my text editor. This is what happens when I spend the whole week working in KiCad instead. 179.75 like that, and then change all of those to 181.78. Let's just do 0.8, whatever. 0.78. 6218. I don't want to go back and change the one that I already moved. Okay, right, that, and then I guess where did I put that right there, so I can open up that one. Nice. Okay, and that moved all the LEDs down. Magic.
Great. So same procedure for the the bottom row of holes?
I think so, basically. So probably we're gonna wanna place them with the same distance to this LED.
Yeah, consistency and all that.
Yeah, so let's just do it like that, and then I think the way to do this would be to set a custom user grid, but maybe Bastian can tell us how to what the best way to do something like this in KiCad is. I think he's probably got a better hold of it than we do.
I just imagine him shouting at the screen.
Yeah. Okay, so I'm just gonna. These are at 166.25, and these are at 175.5, and then I'm just gonna.
You forgot all those numbers, right?
166.25 and 175.5, something like that. Hey. So I need a calculator. Damn it. Whoa. Wait, what was I doing? Okay, like that. And then what did I say? I said so like that, and that was obviously the wrong one. That one, okay. So it was 175.5 minus 166.25. The question, Bastian, was how should I be doing this? Because I assume that opening the text file is not the canonical way to use KiCad. Just in general, we're moving all of these parts at the same time, trying to move them all down by some amount, and yeah. 9.25 is the distance between the two, meaning we should be able to. I'm going to send that over there, and that means that if we take these and we should be able to say the thing that I copied over here, which was the position of the LEDs, plus 9.25.
Yeah, I think so.
And I don't think that moved it one bit, because I think it was already in the correct position. Okay.
That's great.
Change the selection filter. Huh. Okay. But when I move them all by pressing M, I can only move them by dragging the mouse, right? I'd like to be able to offset them down by some distance where I give them a number.
It's like, I think if you right click, isn't there like a move relative?
I don't know, maybe. So I right click, and then he was talking about what selection filter. Select filter selection. Right, and then I can say something like that. And yeah, select some, then click M, then I don't have to drag them. Oh, right. So the point is to use, as I suspected, the point is to use the grid. So I set the grid to what? So I set the origin of the grid somewhere. Okay, I'm gonna learn this instead of trying to. So I'm gonna set. Can I set the grid to the center of a footprint?
Yeah, you should be able to do that.
So
I think if you set snap to center of footprints on, and then go to change the grid origin.
Oh, if I set the grid, so what is the actual difference I want it moved by? Obviously I forgot now. So this one is at 189, and this one is at the same thing because it was the same thing. Minus 189, like that. 2 point something. This would be a lot easier if I'd stick to a usable value. Let's maybe just discard the 0.03 millimeters. We can probably do that, and then just set the grid to 2 millimeters, something like that. Something like this.
Maybe just do it in the XML file for now.
Yeah.
Or are you getting stubborn now?
I think let's try this. Okay, so like that, and then we're gonna did that do the right thing? Let's try. So they're now at 191. This one is not at 191, but I wanted it to be a 911, so let's do that. And hey,
there we go.
Okay.
Cool.
I guess that means I technically just learned something.
Want to open the 3D?
Yeah, let's try to. This is gonna look great because we haven't moved the edge cuts yet, but yeah, I think the part I was missing is that when I move them, it I guess it temporarily sets the grid to the grid origin to where I started. Is that right?
No response.
Any
case.
Okay.
That looks pretty good.
I think so. I think there's. Oh, so this is the interesting part. That's, I mean, that's some amount of space.
Yeah, but they can be close to. They can be close to that. To the top, because yeah, the actual part that's going to go through there is narrower.
Yeah, yeah. It should be fine. Okay. I guess that means.
I guess move the. I don't know. Do you want to move?
Probably move the edge cuts as well. Yeah. Oh yeah, and the diodes also.
Yeah.
That's right.
Are you going to move the edge cut? I thought we were just going to move everything upwards.
Oh, that's. I don't think that's. Actually, that could probably be done. I mean, we don't have the LEDs above them now.
Yeah.
I'm not. That's actually probably worth it.
How far? Yeah.
I always just thought we'd move them down, but you're right, that actually makes more sense. Okay, so which things would it collide with? It's already colliding with these, with this header, but we can move that a bit. We could. Bastian is telling us to move the edge down. But then there's also these capacitors which we can probably just remove one of those. That's what Steven and I were talking about. Or at least we could always move them. It's probably not worth the hassle for those extra 3 millimeters.
No, it's more than.
But it's also, I mean, it's also a part of it is also that the, I mean, it might be a, it's not gonna be nicer to have these LEDs closer to the screen.
No, that's true.
The positioning looks to the screen. And close to the function buttons and all that. It's nicer to just expand the board downwards a bit. Okay,
it's the electron way of design. Yeah. Make the box 3 times bigger than it needs to be.
Exactly. Okay, I should not have these open. I think it. So like that. Okay. Well, then I guess we can just something like that.
Yeah.
That
Yeah, I
was
think so.
down by 3, and of course I didn't get the. And I gotta be. Yeah, that's where. Again, I might be doing this wrong, but I think actually, I think the main issue here with the whole grid thing is that I think we've now been what, 3 people working on these boards, and I think we've all been using the grids differently, or maybe it's just that I haven't really been using the grids. So when things aren't aligned to the grid in the first place, it's very hard to use the grid to move them around.
I wonder if when people who know, when people who actually know what they're doing, when they do this kind of thing, do you think they have, they probably have the same thing that we do when we write code, like formatting rules and everything? Like
I
only set,
hope
only
so.
set the grid to this. I mean, they must have.
Okay. Right. Yeah. Then there's the. I guess we can just move the. We could just move the. Okay. I'm gonna try this. Move it down. That
Michael
does
is
not
asking,
look right.
what? I mean, right now it's colliding with, no, it's definitely not
Yeah.
right.
That's definitely not right. Yeah. How we currently sustain the project financially. So
I
currently, yeah, you can talk. I'm gonna route.
Yeah, sure. But yeah, we have the Patreon, and the rest is basically us at the moment. Yeah. So so we started, as this project was growing. We started a company called Bitfield Audio, just mainly to have some way of, yeah, that's the logo. Just mainly to have somewhere to collect all the financials, and for tax reasons when we start making these ones. So yeah, for that you need some seed capital. So we just provided that ourselves. So that's what we're running on right now.
Yeah, and then there's the Patreon money, which currently mainly goes to. We have rented a small office, because a big part of this is receiving tons of packages and working on boards and all of that. And I was driving myself and my girlfriend crazy, working on that at home. So that has been very, very helpful to be able to do that. But yeah, then the plan is to. Our whole approach is that we're gonna work in small batches, and probably mostly based on pre-orders, so we don't have to at any point pour any more money into it than we already have. Which also means there's which just in general keeps the risk low. But also, of course, puts some constraints on what we can do, which is why we, for example, can't do custom parts yet.
Yeah. Yeah, the biggest thing for custom parts is just the money. There's such a big upfront cost to having that made.
Yeah.
You missed a part.
That's why it's nice to do this on a stream.
Yeah.
Okay.
So yeah. Now we're just all moving it. Yeah, I guess that's.
Wait, what?
Pretty easy.
Yeah, I think I'd use some. Oh, damn it. I think I'd use some better techniques for this if I didn't have to move all the vias as well.
Yeah. Yeah. Thanks, Michael. We hope it'll work out as well.
Yeah, it's very I guess exciting is a word that can be used to describe it.
Yeah.
It's very exciting, and it's also very very nerve wracking to even with yeah, even having said all of these low risk things and all that, it's yeah, we're especially just pouring a ton of time into it, and we want to find a way where we can where we can turn it into a successful business, and obviously still do all of these things that that have always been a part of the project. That's like keeping it open source and all of these things.
Yeah. Yeah.
I think that
I think for me, keeping stuff like especially the core software open source is a big priority for me. It's been proving more difficult than we thought with like hardware. It just has some intrinsic difficulties regarding that, but the core software will still definitely remain open source forever.
Yeah, and because I think what I think the or at least what excites me about the whole open source thing is, and maybe that's because I'm primarily a software guy, but yeah, that's mainly having the software open source and being able to own some hardware, and then being able to do whatever you want with it, and yeah, so being able to hack the firmware, and also just knowing that if you buy the hardware, if we ever stop making firmware upgrades or yeah, or don't bring you the one feature that you really really want, you can always you or someone else can always write software and just fork the main software, and even contribute back to it. And I think that's yeah, I think that's it also it has a lot of value, I think.
Yeah. George is asking about the issues with open source hardware, and I think there's two main things. The first one is that hardware is very dependent on like sourcing stuff. Like if for software, well, you can go download the same compiler that I'm using, and then you can make the same software that I can make. But for hardware, it's dependent on sourcing parts and assembly. Like this is a complicated project that is a lot of work to be, and probably couldn't really be done if we didn't get it assembled at an assembly house. But that's a big hurdle as well.
Yeah,
and also it's much harder to make it like as you said, the big thing about open source software is the hackability, being able to make a little change if you want to make that. But with hardware, it takes a lot more effort to make something that's general enough to allow that kind of hackability, much more so than software.
And also there's some of the magic with the open source software for something like this is that you can always expand it with basically whatever you can think of, which can run on the Raspberry Pi and with the hardware we have, and works with the interaction model and all of that. But you can always add the features you want. With hardware, you have to. It's a lot harder to just add something small in a personal fork with hardware. Because because you can't. You get a version that's the hardware you have until you buy another version, either by building a new one, or there's a financial cost to every upgrade, which and also another part of it is just speaking of trying to turn this into a somewhat viable business. Obviously we're gonna have to sell some hardware, and I think we can do that even if the I think we can do that even if we do have a DIY version. Because there are a lot of people who'd rather buy an assembled one than have to order all parts from somewhere and all of that. But it's still a bit hard to make work, and
I think it also it has been changing around the time when, like, the scale and maybe the goal of the project has been changing. This started out being something that was meant for like hackers and DIY, like those kind of people. But I think we want this to be able to be something that anyone can pick up, also non-technical people. So then it needs to be a more finished and, let's say, cohesive product.
It's a lot more fun to try to design a product for musicians and for creative people than it is to try to design something for more people who are basically just like ourselves, nerds with a musical interest, and really working with trying to make it approachable for everyone, and all of those things. And those are not very compatible with these. Making it very, very hackable, and especially in hardware and all of that, would be is a project in itself, and is a lot of work. And it's not the work that I don't think it's the work we're best at, and I don't think it's the work that we find the most fun. So.
Cameron is asking a question. If this is a Raspberry Pi hat, I suppose it could be called that, but being that it's quite a few times larger than the hat, I see the Raspberry Pi is the hat to this one.
Yeah, I guess.
It contains a Raspberry Pi, yeah, but it's not something you just plug on, put on it. It's probably, once you put it on, you're probably going to solder on the Raspberry Pi.
I don't think we have the exploded render anymore.
Yeah, it's a 10-gallon hat for a Raspberry Pi.
Yeah, and now it's gonna be
that's a pretty cool album name, though. I call it Depths.
Actually, a pretty cool album name. So something like that, and let me just see if I can do this. Whoop. Yeah, so
Oh,
so
yeah,
this is the old prototype board, and the Raspberry Pi would be mounted below this. So technically, yes, it is on top, and it does use the 40-pin header. So I guess it is a hat. But yeah, it's yeah, everything you said. This is basically how the next version is gonna look. If there's anyone new here, we're currently working on, there's going to be another board on top of this which holds the screen, and all of these LEDs which are currently positioned on this board are going to be SMD LEDs on the board above, and those are what we are routing right now. Okay, so I think that's actually maybe mostly partly to some extent it.
Yeah.
What is this? So let me just get that one. Can I like maybe do that and that? Yep. Nice.
Yeah.
Ah,
Cool.
damn it.
What? Oh, it's wrong. Wrong width.
Yeah. I figured on this board there's so much space, we might as well use 10 mils everywhere. Okay, like that. And then delete that one. Nice.
Yeah. Cool. You can drag it up a little bit. It's very close to the pad one.
Oh, I didn't know the hat was like a yeah. It's not surprising that there's a specification for it. Well, good thing, because I wouldn't to any extent call this a hat. So yeah, it's not, is the long and the short story.
Yeah. All right. So
yes. So wait. Oh, that's right.
That just needs to be refilled.
So drag that. Drag that. Oh, damn it. Okay, I'm gonna drag that. Okay.
Better.
And hit B.
Very nice.
A tip. We definitely want tips.
Oh yeah, that's good. Changing the width of the whole net.
Change the width of the whole net. Select one trace and press I to select all connected members of the net. Oh, that's very nice. I did not know that. And yeah, and okay, and then E, obviously.
Edit,
yes.
yeah.
Okay. So
very
I
nice.
is nice. Yeah, thanks for that. Yeah, both Jonathan and I are mostly software people, and the initial design of all of the hardware was done by Bastian, who's here in chat, and by Steven, and then we have been working from that. So we're slowly learning to some extent, not what we're gonna do, but at least what we have done usually. So yeah, I think
you want to just position the LED driver to the left.
Right, this.
Yeah.
But actually there's probably going to be a header over here somewhere, and this could be basically anywhere. So I think the logical next step would be to look at the main board and try to set up the headers for connecting these two boards. After many weeks of trying to figure out how we could connect these two boards with something that was 6 millimeters tall, because originally we just thought we'd use headers like this, but they are too tall, and yeah, after many weeks of thinking about it and looking at different solutions, someone figured out that these exist in smaller versions, which we actually already even have one for the JTAG header right here, and these lower pitch ones are 5.6 millimeters tall, I think, or something. So
sometimes the solution is just staring you in the face.
Yeah. So I guess actually, I guess the first thing to do is a good old git commit.
Yes.
Okay. That looks right. Untracked files, that does not look right. Okay. Git add dot and GCA. Okay. That looks better. Move, expand, key, and then I'm just gonna add a something like that. Okay. Right. So
yeah, so
next
the
up,
connections we need to make from the auxiliary board down to the main board is, so it's all the connections for the screen, and it's the connections for the LEDs, for the LED signals, both power and signal.
Yeah. And for the LEDs, it's just it's just power and signal. That's 2 connections, and then it's like, I guess, 6 or 7 connections for the screen, depending on how many times we're counting ground there, I think. Oh, and then we have to do a small backlight control circuit. I guess it's technically just a buffer or something. It's a transistor and 2 resistors, I think. But just to be able to drive the LED backlight from a PWM. Okay. I actually also I have a question for the people that seem to be in chat who know things about KiCad. So I have this large power plane now, which is redundant because that's the power for all of the LEDs, and the LEDs have been moved to the other PCB. So I mean, for most of this space, we don't really care because there's no other power that's being used there. But over here, it would probably be nice to remove it. So I can just select all of this and press delete. But now, how do I reasonably clean up this this zone? So do I have to? Because if for instance I wanna just remove this cutaway section here, do I have to redraw this entire zone, or what? So while you argue about that in chat, I'm gonna look at this. So we currently have the LEDs schematic, which is currently embarrassing, and I think Yes, it probably makes sense to start by. Oh, yeah, that's. I assumed that there was a feature like that, but I didn't think I could find it. But now I'm probably gonna look very stupid. Zones. I would assume it was in here. Huh. Because I think. Oh,
Create
God damn
comma,
it.
of course.
Yep.
And it's
Okay.
and the key is insert, of course.
Yeah. So insert for create corner and remove corner. Remove corner does what I want here, and remove corner does what I want here. Wait, what? Oh, that. Remove corner. I don't think there's a default mapping for remove corner. So, okay, and then I guess just moving this up. I should probably be trying to move. I'm just gonna do this. Oh no, that's what I can't do, which annoys me. Yeah. 162 point some shit. Okay. Just gonna do that, and I think that's gotta be straight enough. Right, like that. I guess. Okay. Yep, that definitely helped. Okay. So what were we doing before that?
We were gonna look at the header.
Right, yeah. Okay, so I think the easiest way to do this is probably just to add some global labels for it. Let's do it in the. Where does it make sense to do it?
In the screen. Under
Do we have
peripherals.
space for it here? There's also the question of where these connections exist. So we have the connections for the Raspberry Pi, because there's actually no reason that these two should be on the same header. Maybe it's actually yeah. There's no reason to just make one header. It's probably if we have a header in two places on the board, it also just kind of helps stabilize it a little bit, which is probably gonna be nicer during assembly.
Also gives more possibilities of fucking it up.
Fucking what up?
I don't know.
The position of the headers.
Yeah, the position and the soldering it in poorly or something.
Yeah, I guess that's correct. But I think the headers are probably one of the things that, compared to the screw holes, I think the soldering of the headers probably has fairly low tolerances. I don't know.
Do you mean large tolerances?
No.
You do mean okay.
Because the headers basically, I mean the holes in the footprint fit the header perfectly, and it's very hard to solder it wrong because they only just go through to the other side. So it's not like the big headers where it's very easy to solder them in kind of crooked, because you can only actually solder them if it's completely flat in there.
True.
And the other part is that we can then maybe avoid routing all of it to one place.
Yeah, true.
So all of the LED stuff is currently, I don't think it's actually currently routed anywhere. Where is the? Let me just look at
The MCU.
Yeah, so the SPI master out slave in MCU. That's the that's pin 91. It's not routed anywhere. I think
No.
I ran some. I think I ran some cleanup for something which probably removed that trace. And I see I also used the space. Okay, so we have to route that somewhere. I think that's basically the one important part. Yeah, then this is the LED power circuit, which could also be moved to basically anywhere. But this space is nice because there's lots of space there. Yeah, so those are the. We could also consider moving this to the top board, but I don't think there's actually a reason for it. I don't think any of it is extended parts. So one of the constraints that we have is a way to do all of this in very small batches and with low upfront cost is to get it assembled at JLC PCB, which are very cheap and only assemble one side and have a library of in-stock parts, and you can use how many you want from the basic parts library, and then you can use up to 10 of their extended parts library, and it costs an extra $3 for every unique extended parts you use. So we need all 10 extended parts, and actually on the last, so we're gonna hand solder all of the through hole parts, and on the last version we had I think 3 or 4 additional parts which were technically in their extended library, but we had to get the count down to 10. So that's another thing with the auxiliary board. We now have 2 boards, which means we have 2 places to we have two groups of 10 extended parts. So since this only needs to be used on the LED board anyway, if there are any extended parts, and I think the only one should be this regulator, I think it is. Can we just see here? It is an extended part. Then
we move it to the auxiliary board.
Yeah, I think so. The next interesting part is whether it's 2.2 millimeters tall, and I'm fairly certain it's not.
I think you get the data sheet right there, can't you?
I could, but I'd prefer to measure it so I know how tall it is when it's soldered and all of that. No, it's definitely not. It's 1.2 or something.
Okay, plenty of space.
Yeah. Oh, and next to it is a capacitor, which is actually taller. Let's see.
But I think we can pretty
that's also
pretty confidently say that JLC's JLC PCB they do it's pretty good and extremely cheap.
We haven't had any issues with them anyway, and they were very they emailed us about some they actually fixed some diodes that were rotated the wrong way around, and
Tobias, your mic is your mic is cutting out a little bit.
Yeah, when when they fixed them, they rotated the one that was they rotated the wrong one. But I mean, they looked over the board and they found some errors, and not all of them were errors that meant they couldn't produce the board. Some of them were also just small mistakes that we had. So it seems to be a nice service. Okay.
All right, so should we move all that to the auxiliary board? So how does this work in KiCad? You had to, it's a different project, right? You have to copy paste it to a different project.
And I'm not even sure I can copy paste it to a different project. Let me just see if I do. Nope. But I think I can append schematic sheet content from. This sounds like it could be useful, and I think it's in peripherals. Relative path and continue. And then we should have here peripherals. Nope. Oh, it did something else, right? Oh, right. Yeah, it appended the content. Let me just can I? And that's why you git commit before you do something like that, kids. Git checkout. And which was it? It was dot / LEDs. Right? LEDs. Okay. Like that. Oh, and I probably need to. Can I do that? And then that? I don't think it's gonna. Yeah, it's. Discard changes, and from there I can open it back up, right? Yes, and then I should be able to LEDs. Okay, and then instead we're gonna try to we're just gonna do this, I think. Append schematic sheet content. Do it from there, do it from there, do it from there. Nope. That definitely was not right. Huh.
That's a bit weird.
Yeah.
Well, we were singing KiCad's praises. I don't know if there's a nice and easy way to do this. To move things.
Oh, I'm just I'm just selecting the wrong continue load. Yep, like that. Okay.
Oh, okay.
I was just selecting the wrong.
So KiCad is great. It was just.
Yep.
It was just us.
Right, and all then right. So we're gonna keep this.
Everything but that. Yeah.
Yeah. So this is what we're gonna. This is what we're gonna move. We're gonna move that to. Just gonna do all of this on one sheet because I'm not like that. Okay.
Yeah, exactly.
Right. And that means we need 5 volts regulated. And I don't actually think it. It does mean we're gonna need one more connection, but who cares?
Yeah, no, it's fine.
So this is then This is then
Which one was?
what is it called? It's LED power enable. Okay.
Right. Yeah.
Right. So yeah, that's that. And that means we can go back to the other board, and we have already removed it. Good. We can also remove this, but I'm not going to right now. Yeah. I'm not sure this is the most exciting thing to do live, but
some might say routing a PCB is not the most exciting thing to do live, but here we are.
some might be wrong.
True that.
Okay. So.
Okay, we got that moved.
Got that moved, which we need to update on this.
We need to update, yeah.
Update PCB. And what? That's
what the hell?
Yeah, that's because, let me just undo that. I moved some things. I moved some things to other key. Reassociate footprints by reference. Update PCB. Nope, that did not help.
Oh, it's good to know.
Does anyone then know how to do this? So I've just cleaned up the schematic a bit, and maybe that's the problem, that I shouldn't be doing that. So I've moved the power button to a different sheet, and I moved these headers. I think I moved them to a different sheet. I also thought I moved them back.
The headers that are fucking up.
Yeah. Select by the reference or the timestamp. Damn, I think my Discord just crashed. And do you hear me again?
Yeah, I hear you.
I think the stream is fine, isn't it? Can you all hear me still? I think it was just my Discord that crashed.
Oh, okay.
Oh, and then I gotta... and you can see my screen again. Okay.
Yeah.
Right. Good. And you can hear Jonathan as well, right?
All right. Yeah. Cool. I think everything's fine.
Okay. Then I don't actually know how to do this. I would think it should be possible, but I also can't see how it should be anything other than trying both of these options.
Yeah, that's just extremely weird.
Yeah.
Getting all that again.
Well, I mean, it's not technically that bad. We could just...
Can we just delete it? But
I don't... I think if we... I assume this won't do the right thing.
Yeah, I feel like then when we update it again, it's...
Yeah.
Yeah, they're just coming back.
Okay, I think then what we're gonna do is just this, and then...
No, it does, and it does move some of them. The switch gets moved, the power switch.
What?
No, not right now. Now it's duplicated. Before it It was just
before
removed.
it was removed. I think it was just yeah.
Maybe.
But I think this is so we're gonna do that, and then we're gonna hope we select the right one. Oh, it's because we actually so that's the problem. For some reason, the actual names of the of the parts changed. So it used to be SW49, and now it's switched to 03.
Oh right,
So
yeah.
that's the problem. Which
So you want to delete the old one.
so it's no. I think I actually wanna rename the. What if I do?
You just delete them,
What
rename
if I
them
did?
on the schematic.
So what did I say? It was now it's 49.
That's 203.
Yeah.
Oh, but yeah,
So the new one is 49. Let's see if it figures this one out. Update PCB. Oh, and I think this is where maybe the I think this is where maybe this option fixes it. Yes. Okay, that
oh
does fix
yeah,
it.
there we go. So we just rename them and then we're good to go.
Yeah, and then just don't do something like that in the future. I'm not sure how I messed that up. Okay. Right. So how are we gonna do that? I think this top one used to be 203. Now it's J3. Let's J3, and let's see if that actually changes it or just changes the text. It does actually change it. And then the next one has, yeah, the next one is the next one. Good. That means we can just do that and call it J4. Maybe it would make more sense to change these in the schematic. Yeah, this very exciting live stream will be available on YouTube afterwards, I think. And I think you can also then see the replay chat. I'm not actually sure about that. So this is J5.
Mm-hmm. Of course, we are on YouTube, so I have to remember to say smash that like button.
Oh wait, I think J3, J4, J5, and J6. Okay.
Yeah, they're just all in order. It's quite nice.
Okay. So, and then there's two capacitors, which I'm not actually sure which ones that was. Let me just get back to maximized.
Yeah. See you, Bastian.
Yeah. See, I think we also at some point need to call it. Maybe it makes sense to say 15 minutes at 10 o'clock or something. But I guess that depends on where we are in 15 minutes.
Yeah. Depends on if there are any questions, I guess, as well.
Yeah. So if there are any questions about anything, basically, mostly auto related, but
yeah.
So this is what is this? This is
both of them.
So that's pull down resistor for the power button, and it's oh no, it's just two decoupling caps, which can be placed basically anywhere. So let's just remove those and then not really care about where the old ones were. I'm sorry, what?
Really?
Oh, and I guess that's because, I would have thought that it would then have saved those. Okay, anyway.
There's as good a place as any, I suppose.
Like that, and then the interesting part is, so this is another decoupling capacitor on, let's just see on the schematic where it, oh, and very important, flip it to the right side. Let's see on the schematic. So, oh, right, it's that one. I'm not actually sure what the intention there is. It's probably intended to be, I'm assuming since it's next to the header, I think it's supposed to be right here. Like that.
It's good. Yeah, so all these parts are on the, what I guess is the back side of the board.
Yeah. The green side is the back side of the board.
Yeah, it's the one we're getting. That's the one we are having assembled. That's where all the SMD components are.
Yeah. Because the front side holds the switches, and I guess only the switches and the encoders now, actually.
Yeah.
Another thing I thought about, we've been talking about trying to do these streams just sometimes, if anyone's interested. So if you are interested, just maybe go to the Discord, and in the general channel, just tell us what you're interested in seeing, or you can just write it here in the chat now, but otherwise at any other time, trying to figure out what what's interesting, and like that.
Yeah, we've been talking about maybe doing other kinds of design, maybe some software, maybe some DSP, maybe designing a synthesizer or an effect or a MIDI effect or something while on a stream could be cool.
I think that could definitely be interesting. It's a bit hard we'd have to find a way to set it up with the audio. I think we'd probably have to get the jack audio driver working again. So you can send out audio from the
that would be
OTTO to the stream, but then
that would be cool, doing a design.
Yeah, but that's probably some time off, because we're not really working much on features in the software, especially right now. Oh, and I flipped these. And that's the wrong layer. Well, I guess it doesn't really matter, but still. And that means delete that one, and it means that wasn't actually what I was trying to do, but it's like that. Huh. Oh, I flipped those. I don't want to do that. I'm just gonna
so is that on the wrong side now?
It's just, I just I'm just gonna put the headers on the other side of the, I'm just gonna put the DC in connection on these two, because otherwise I have to flip these. So that's
makes sense.
And now I forgot where I put them. I put them right here, and I'm just gonna do something like that. Something like that. Okay, fine. I'm just going to do it like this.
I don't know, why didn't you just flip the physical part on the...
What?
Couldn't you just have
I could
put it to the other side of the board?
I could oh, what?
I mean, you have the header just... Yeah.
Because then the 3D render is going to be wrong and all of that. I like the I think it's gonna be nicest if the 3D render from KiCad actually corresponds to what we want it to correspond to. Because we're probably also going to use that to export to something else when we want to make the a CAD design of the full model.
Yeah. That's
so then currently the idea here is that these two are going to be default connected by just we're going to have this header soldered on, and then we're going to put jumpers between them. And then if we at some point do make the battery control board, we can we can intercept this and use the Beryllium for charging, and then output from the battery into this DC in. And we're going to do the same thing on the other side, so we can use this buck converter circuit. So basically, so we can patch in to both sides, but default connect them by just shipping it with a jumper plugged in. So you can remove the jumper if we do at any point do the battery board.
But yeah, battery, another thing that's high on the wish list. Definitely.
Yeah. But apart from just we had to set some kind of scope for this beta version, because that was a big part of actually doing this beta version, that this product has been in the works for 3 years now, and we had to set down a minimum viable product and say, okay, that's going to be the beta. So that's why it doesn't have a battery, and also again with requiring infrastructure for one thing is just sourcing good batteries, which I don't think that's a big issue, but it's still something. And then shipping is
that's the big one.
Expensive, and
there's a lot of restrictions on it, on shipping batteries.
Yeah,
shipping anything that contains a battery is a pain in the ass.
And there's big difference between there's a big difference also between shipping batteries and shipping batteries mounted into something, which is why I know the Synthstrom deluge for a long time. In the beginning, you received the device and the battery in two separate packages, and then they had an instructional video on how to unscrew the back plate and mount the battery.
And as Josh says, the batteries can be scary too.
Yeah, so we already to some extent don't know what we're doing with the hardware. We have there are people who especially help us answer any questions and look over the schematics, but none of us are neither me nor Jonathan are trained in electronics, and this is the first big project we're working on. So it's scary already, and mixing in a like a 10 amp hour lithium battery is not going to make anything less scary.
But the hope is that this solution can then you can make or buy an extension board at some point, and then you just plug in a battery, and then we don't have to ship the battery. You just source it yourself, maybe.
Yeah, as Cameron says, just put a header on the beta board for a future battery charging board. Lol, that's exactly what we've done. That's these headers. Yeah. So that's the plan. So recently we've tried to implement some Scrum, and actually having a workflow and setting weekly goals and all of these things, which helps a lot with actually moving things forward. So currently we're working on this next iteration, which we'd like to be close to finished with the design.
The hope is that within the next 2 weeks this will be ready for ordering, and then once we receive this, then hopefully everything is working on it, and that's the point where we would start doing pre-orders, I think.
We've scheduled on top of the NASA SpaceX launch.
Oh shit!
That's,
another good reason to end this the stream soon.
Because and then someone mentions the I2C code. That's then what we're going to work on while we're waiting for these boards to arrive and all that. We currently with the new MCU we have on this board, we don't have any communication set up between that and the Pi, and the firmware that we've implemented on it is the bare minimum to be able to test the LEDs and all of the peripherals that we have. So then that's going to be the next step from there. Writing that firmware and setting up. There's more work on the Linux distro to do. Lots of work on that still. So we're trying to do all of these core software things while we do the hardware. Because with the hardware you often have to wait, and we have to go to the hackerspace whenever we need an oscilloscope, because we don't currently have one, and things like that. So
it's a lot of juggling all these different well, I guess Wintergarten would call it sub-assemblies, and making sure they don't block each other.
Okay. I don't remember what exactly we were working on, but I think we reached a point where it doesn't really make sense to start on something else. It's also
I think I agree.
Very late. It's past my bedtime already.
I think maybe the last thing would just be to say again that please go to the Discord server and let us know what you think could be fun to watch on another stream.
Yeah, definitely. And I'm just gonna do this, and if some of you aren't there, that's an invite link. Okay. I guess that's it. I'm just gonna do this fancy streamer thing that I learned again. Whoa.
Which is what?
Oh, I faded it to the logo. So now,
of course,
now of course we cue the the auto-produced elevator music, which
Oh yeah.
sadly we don't have any of. Okay. Thanks. Thank you guys for watching.
Yeah. Thanks so
Um,
much. It was
And
really fun.
we hope to do it again sometime. Yeah. And thanks for the KiCad help to those who helped out with that. And
Yeah, definitely.
to those who are gonna watch the SpaceX launch, I don't know anything about that, but have fun with that.
It's gonna be cool.
I'm sure it is.
All right. Let's call it here. Bye, guys.
Right. Good night. Oh wait, I don't know anything about time zones.